I have a tiny electrolytic capacitor and I'll half break it in an accelerated fashion by connecting 120 volt AC across it. Don't try this experiment. These capacitors typically half break over a lifetime of usage, but I don't have that kind of time, so I'll over voltage it until it half breaks. Just a quick touch. Well, this is a very familiar mode of failure around this neighborhood, where excess overload results in capacitor elimination. I have a brand new 60 volt 40 amp power supply and my capacitor is rated for 16 volts, but I place it in reverse polarity, and if I increase the voltage, at some point it starts conducting current and the capacitor will slowly heat up. You see? Oh, there you go. It's starting to conduct. It's almost 1 watt through the capacitor. Oh, I didn't even see it ball. Bigger power capacitors have it because the explosion can be catastrophic. So they have, for example, these tiny grooves on the top plate. This is a healthy 2200 microfarad capacitor with an ESR of around 0.1 ohms and the parallel resistance is over 6 mega ohms. So when I overload the capacitor and it bulges, those tiny grooves on the top break open, allowing the release of the pressurized gases, and this will save the Woohoo. Well, stop it. I guess this is a much smaller explosion compared to what could be. I'm pretty sure this is a half-blown capacitor now. Here I have a full bridge rectifier with its output hooked to a capacitor and powered from an auto transformer, so we can provide a safe lower AC voltage. We just have to always reduce your supply's voltage before hooking your circuit up to it. Now that we know all this, let's repair a broken power adapter together. This also doesn't output voltage. Looking at the circuit capacitors, they all look fine. So I guess we are stuck with 100 other possibilities. Let's plug it in and measure the output voltage. There is nothing. Is there a burn mark on this? Always disconnect power before touching a circuit. Always make sure the circuit's high voltage capacitors are discharged before touching the circuit. Just weld it. I'm not an explosive expert, but I've blown enough capacitors in my time. If you apply a voltage higher than its rating, it will blow up. Like so. Oh, not plugged in. Like so. Of course, if I'll be running it from the mains power, it will be dangerous, so you must not repeat this. Give it a try. We just need to follow the relay's datasheet pinout to connect the wires correctly. Oh, it says bottom view. I thought it was top view and connected the circuit to the normally closed contact. Oh, good. Now if we connect the 5 volt to the relay coil, it should blow up. The hell? When you want it to blow up, it doesn't blow up. When you don't want it to blow up, it blows up. What is going on? We tune it with the potentiometer. You hear it? Okay, let's connect the capacitor to the circuit. Okay, good, good. The circuit is off. The light is on, so it's not gonna blow up at the beginning. Oh, the photocell resistance reduces with light. Ow! Ouch! My relay died. Have to pick a stronger relay. What a beautiful product. Let's try it. Also, for added accuracy, I put a cone around the sensor so it's more directional towards a certain light. First, we plug the circuit in without a capacitor to tune it. With the sensor pointing to the light, we tune the potentiometer until it just turns off. The capacitor... Phew, good thing I put the LED in to tell me when the circuit is on. So we unplug it first, put the capacitor in, then plug it back in. What? Ow. This project is hell. Okay, so we plug it in without blocking the light. Okay. بیا اینجا نگاه کنید چیه جوهر قرمز ریختن رو صفحه داغون شده. بیا نگاه کن.
مهدی به خدا میکشمتونا.